Welcome to our demonstration video. In this video, I'm going to introduce our tool named Paoding, a high-fidelity data-free pruning tool for deep loading pre-trained neural network models. Nowadays, most existing deep learning optimization techniques, including model pruning, are known to be data-hungry. However, from the model user's perspective, this may not be realistic, as the model trainer may be reluctant to share the original training data to the user. One real-world example is the Facebook Deep Face model, which is trained with a huge number of human face images. Users can run the model but have no access to the training data. Similar challenges can also be found in machine learning as a service and federated learning paradigm. Our work is also motivated by the recent trend that many countries around the world have started imposing a very strict regulation on data protection. For example, the European Union's GDPR and US CCPA. The owner will face a heavy penalty if they are found to violate those data protection regulations. For those reasons, data-free optimization is of great significance. To address the challenges of data freeness, in this work, we propose Paoding. First of all, our tool aims to perform pruning in the data-free context, which echoes the data minimization principle of GDPR. More specifically, our pruning does not require the original dataset for retraining or fine-tuning purpose. Unlike many existing pruning approaches that prune scattered parameters by zeroing out their values, our pruning can physically delete the entire neuron from the model, and thereby substantially shrink the model size. Most importantly, because we are not given a chance to retrain the prompt model, those existing pruning that adopts an aggressive cut and retrain strategy can no longer be applied in data-free pruning. Our data-free pruning aims to well preserve model fidelities in terms of the test accuracy and robustness, just like what data-hungry pruning approaches do. Our approach is open-sourced and has been released as a public Python package on the PyPI, so you can use Paoding by just simply run one line pip install command. The latest version of Paoding is compatible with any legitimate MLP and CNN models on TensorFlow and supports pruning of fully connected and convolutional layers. This slide shows the workflow of our approach. It begins with reading a pre-trained model and loading its parameters and configurations. Then, it iterates all the convolutional and fully connected hidden layers and performs pruning in 3 stages. First, it traverses all neurons of that layer and samples the pruning candidates based on specific strategies according to the layer type. Given a list of candidate neurons, our approach performs pruning. We apply a surgery approach that deletes the candidate neurons from the model. Our approach shrinks the convolutional layer by deleting some channels for every filter. For fully connected layers, we directly cut off the entire hidden unit, including the BIOS and all its connection to the previous and next layers. Once the pruning is accomplished, we reconstruct the model with the pruned layers, and thus the pruned model has a strong architecture and a smaller size. Next, I will show you a quick demonstration video. In this video, we use Paoding to perform a 25% pruning on a pre-trained convolutional neural network model. Let's start. It begins with loading the pre-trained model. Now you can see the original model contains over 783,000 parameters. And you can see our pruning is implemented as a conservative and progressive process. So we perform pruning in multiple steps, and in each step, we only prune a very small number of neurons in each layer. In this demo, we prune only 5% of neurons per step, and the 25% pruning will be separated into 5 steps. Now we are almost there. So after the 25% pruning, you can see that the prune model only contains 484,000 parameters, which is only around 64% of its original size. In the end, we welcome our audience to feel free to have a try of Paoding. Thanks for watching this video.